All right, factoring Algebra 1. Technically, we're in section 8 and 9 here of Algebra 1, and we're looking at perfect squares. But although we're looking at perfect squares, really this section deals with everything. And I really want to take a look at the plan of attack here. How do I attack things? Now that I've got so many different factoring skills, I kind of mentioned this the other day, but we're going to have common factors are the first thing you're going to look for. Then you're going to want to look for special cases. At the time it was just difference of squares. Now we're adding in perfect squares. Perfect squares are a little harder to spot, but if you can see them, they can really be useful, quick factoring if you can recognize them. If you don't recognize them, you'll still be able to factor them the way you would trinomials, either without a leading coefficient or with a leading coefficient. If you have anything that's got more than 3 pieces, you're probably going to want to go by grouping, and then you want to repeat. Okay, I'm just going to go through some of the problems that are on the homework itself. Actually, not on the homework itself, some of the odd problems from the book, right next to some of the ones from the homework, just to kind of see if we can come across some of the things that you might see along the way. So as we keep this plan of attack in mind, the first thing we're going to look for is our common factors. In this case, we have an 8. And if we pull out that 8, we're left with a y squared minus a 25 z squared. And then we go down our list and we see, well, we have a difference of squares. Y squared and 25z squared are both perfect squares. So it becomes very quickly a y plus a 5z and a y minus a 5z. Now everything's down to linear. In other words, there's no exponents left. This is as far as this is going to factor, and we should be in very good shape. I want to look at number 23, and the first thing I'm going to see with 23 once again is that common factor of 3. So we'll pull out a 3, and that'll leave us with a 4x squared minus, I believe, a 28x plus a 49. And this is where we're going to look at our first perfect square. So here we have a perfect square, there we have a perfect square. If you want to think about them real quick, this is a 2x that is being squared. This is a 7 that's being squared. And as long as you see that, you might want to kind of guess this is going to be a perfect square. And if I'm going to guess that it's going to be a perfect square, I'm going to go 2x and a 7, and I'm going to go 2x and a 7. And this sign always is going to be the sign that I will use in the middle here. Or if I'd rather, I can say 2x minus 7 squared. And this is why we call it a perfect square. It's a little interesting to me that when we talk about perfect square, we talk about the factored form is a perfect square. That's when we're talking about perfect squares. When we're talking about difference of squares, if you go back to the last slide, we had a difference of squares that was talking about the unfactored form that was a difference of squares. It's a little interesting that we reference them from different points of view. Okay. Now, truth be told, if we look at this difference of squares, 2x and 7 is 14x, and there should always be 2 of those right here. Okay. Now we can add the negative in we did later, so we had a positive 7 squared. This is going to be a negative 14x because that's how I would get a negative 28 to happen. Really, what I kind of do with with perfect squares is I look for these perfect squares to happen at both the beginning and at the end, and then I think my way through this. And if I think my way through this, obviously the 2x gave me the 4x squared because I knew that perfect square to begin with. The negative 7 is going to give me the 49 that I wanted. What I'm looking at down here is this is going to give me a negative 14. That's going to give me a negative 14. That's going to give me 2 negative 14x's. And does that give me this negative 28x in the middle? That's what I'm looking for, and it does. So this is the factored form that we have here. This next one, I took away the instructions there, but if you remember, the first thing that we want to do is look for common factors. And I'm looking here, and I have in all of these terms a 2a. Okay? Now if I pull out that 2a, that's going to leave me with an ab squared minus an a. It's going to leave me with a minus ab cubed, and it's going to leave me with a plus ab. Now, it was a little tempting to to start by grouping, because if I looked at this, they both had a 2a squared. If I looked at this, they both had a 2ab. It's not entirely wrong to do it, but I think it's better to get the greatest common factor out of everything first, because now I can still go back and group here and take care of this a, leaves me with a b squared minus a 1. Remember, anytime you take away everything, you want to leave that 1 behind. And here, I'm going to pull out a negative b, once again, trying to get the same negative 1 to show up. Now, outside of this whole mess is this 2a still. Don't forget about him. All right. Sometimes I just leave him and I don't write him till the end. I don't want to write him without these bracket. Well, you can use regular parentheses if you like. Doesn't really matter. But otherwise, that 2a doesn't get distributed. And usually, people kind of write their mistakes as they write it, and it kind of takes care of itself. But if I go back to this now, I can look and say, well, there's a b squared minus 1. So I'll pull out the b squared minus 1. That'll leave me with the a and the minus b. And of course, we have our 2a out in front. And now you can see I have 3 things multiplied together, so I don't need this extra set of parentheses around it anymore. Okay, but I also look here, and if you didn't remember on our group, the last thing was always repeat. In other words, go back and check and see, are there any more common factors? Are there any more things that you can factor in? This guy here is a difference of squares. So let's leave the 2a alone. Let's leave the a minus b alone, but that b squared minus 1 squared is a b plus a 1 and a b minus a 1. And this would be my fully factored thing. So here's the thing with this section. They want to tell you it's about perfect squares. Really, it's about factoring everything as much as possible. We look at this one, and we have, once again, a common factor that we can pull out. I think we can pull out a 3k, and that's going to leave us with a k squared minus an 8k plus a 16. And I kept this one in the examples. It's really kind of quick, but it is a perfect square again. I have a k squared, and I have a 4 squared. So I'm looking at this as a k minus 4 squared with a 3k on the outside. There's my answer. By the way, if you're not comfortable going straight to the squared notation here, go ahead and write it as a k minus 4, k minus 4. And usually when you write it as a k minus 4, you can very easily check for yourself. Do I get that negative 8 in the middle? Negative 4k minus 4k? Yes, it does. As a matter of fact, it would not bother me if you wrote your answer this way as opposed to the other way. Either one of those I would take. Got one more example that I want to look at. Obviously not a perfect square. There's not a common factor either. I got g in both of these first two, but there's no g's in any of the last two. As a matter of fact, there's h's in the last two, and maybe that's already kind of pointing us where we need to go. But let's run down our list real quick. It's definitely not a difference of squares. Definitely not a perfect square. It's not even a trinomial, so I can't even deal with that. So I'm stuck at grouping right there. So if I pull out this g, that leaves me with a g plus 2. And if I pull out this h, that leaves me with a negative 3h plus 4. So I've partially factored the front half. I've partially factored the back half. I've actually factored nothing. Okay? So really, I'm going to go back to this is a prime polynomial. I cannot factor it in any way, shape, or form. If I can't factor it, if I can't make it all multiplication, and realize here, this and this, we're still getting added together. So ultimately, that green one that I crossed out was 2 things that were getting added together. It's not a multiplication. The idea with factoring is I want something to be multiplication. Okay, take a look at this example real quick. If I have x squared minus 9, I want it to be x plus 3 times x minus 3. Ultimately here, this is one thing times another thing. That's multiplication. That's what it means to factor something. Turn it into a multiplication of 2 things. Okay, so there you go. A little bit of examples to go along with your homework from the first half of section 8-9.